after each half is way off, the amount of material being is that what you're I don't know what
So, what you guys do when you flip them?
Okay, so
what's kind of what's the chance
that you're going
to dictate? Wait for you. They only have two sides, right? Yeah, so it's a 50% chance. So that means, and then what was halfway? I know. You guys know what it is?
No, it's okay. We just want you to try.
So we got that graph. We like 20 to 10, 5. So what's going on there? Yeah, so it's 50%. So it's a lot like these M&Ms. So with that,
think about the graph you just did. Like how often was it became, or how much of it?
Try to write out something there that kind of explains.
Why do you think we call them half?
Usually maybe that's 50%.
Most likely around half. This is the average.
So you can do it, like for this one, it acts after 3, so I did it. Probably inside.
oh, like actually, this is like at 5.
Like 2.3.
You could divide it by 2.
So divide it by
How many? Okay, divided by 2 3 times.
Good, very good.
Can you make that easier to
Does anybody need a calculator?
65. Is that equal 7 with the
You've been doing this.
Okay, so we get a calculation. If you break it down like 75 and 75, like if you think about it.
Calculator?
65, 65,
Wait, you can think about it, you can break it down to 25. So no 25 times 2 is 50, right? That's a good way to learn it.
There's a specific way. It's just because of the force we toss it.
175 So how many times I do it? Like 100?
Oh, I got you. I see the things here. I know, right?
You know, I put that in a
Is there like a specific M&M you mark that up or trade? Individual sample it will come that way. Did you predict when it would decay?
So we're saying
Oh, definitely. That's the point.
This isn't supposed to be so.
This isn't supposed to be easy, guys. So just try and work it out. Talk amongst yourselves.
We're just saying it
Let's
better.
get to number 5. 5's not tricky. So number 5. Okay.
That's like a history. I know. Once we go after it, it'll seem like little something.
I know the number 7.
Looks like that you did it, right?
Because I put 7 divided by 4 times.
Okay, I feel like you can rock her dick.
Because it's still the same thing.
So the next one was that half. So you want 6.2. So half of 100. All right. Class. So how many of you are at number 6? Number 6? So y'all saw number 5?
No, we skipped it.
I skipped it. Look at it. Come back to it.
We'll do them on the board. We'll do the math ones on the board.
I'll give you a hint real quick. So this is how many half-lives would it take for, I'm not going to try to say that. Whatever. So basically, how many half-lives would it take for this number to decay to 6.25% of the original number of nuclei? So it really doesn't matter how many it is, because if you think about it, most likely something will decay at half rate every single time. So it's going to start at 50%.
And then what's 50 of 50? 50%. Okay, so keep going with that and see how many times it takes to get to 6.25.
Oh.
Right? It doesn't matter what that number is.
Yeah, it really doesn't matter what you start with. It's all percentages.
You can.
So thinking about number 5.
What you said.
How many is that?
What do you mean for number 5?
We'll go over it. I want to do an explanation.
8.8 times 4 is 115. So you take that number and you just, it takes 4 half-lives to get divided by 2. So this is 10 divided by 2. Okay, so what do you mean? Okay, so this one's gradient. I don't know. Half-life. Yeah, radio half-life. Oh, it's simple, Mama. Number 7 has to get 28. So you would do like 15.2 divided by 2. I think
You guys good? I know how to add.
Because it starts off at 20.
You divide that 10 by 2.
for 5.
You divide that
Because I multiply by 2.
You figured out how many times, like how many years, you figure out how many years, or how many half-lives, you figure out how many half-lives, so now you have to divide the brain.
Like by the year that's left, it's about 28.8.
I was thinking
No, so you figured out how many years, 115, so now you have to divide 10
Oscar couldn't add those, girl. I don't know about that one. I mean, he got to it, but
you divide 10 in half.
Okay, and I got 2.5.
There's gonna be 4.
Yeah. Number 7, number 6 is a little difficult. She's trying to think it out. Write something down for it.
It's saying every half life. Every time.
What do you mean by half-life?
Times 2. You need to buy 1 for the 10.
Are you mad because I didn't
They give
divide
you
4
4
out of 4?
for that 4 half life. Which divide also price and report. You got cylinder stuff?
Make sure that you at least answer the last one.
Strontium 9 has a half-life of 28.8 years. If you start with a 10 gram sample of strontium 90, how much will be left after 11 crap, 115.2 years?
What number are you
That's up for
on?
that last one there.
90.
Make sure you get something out of that.
We're 90 is listed with the math page.
Oh, we're done with 8?
That's all 90. This is strontium 90, like carbon 6. It's up there. That's all.
I just wondered.
Wait, no.
They're little math geeks.
Well, there's math on it, and
It
then
has
there's
a
also real
half-life of
tough
28.8
conceptual
years. That's
questions.
how much
That
time it takes to decay one half-life. So,
Half of the other. Thank you.
strontium 9 is 1 minute. It's just like,
What?
about 10.
Yeah.
Yeah, they're gonna learn this. They're gonna learn this today.
And I guess with elements.
Glad you're
You don't
here.
have to pay so much attention to that, what it actually is. It, trust me, when we go over this, oh, this is great.
Yeah, we did teach ourselves.
It just has a half-life, 28.8 years.
Math mind.
How much, that's how much time it takes to decay
So it's like,
one
I know a lot
half-life.
about and I know a lot about carbon.
Find out.
Add is
It's
decay.
not asking for them to try, it's asking how much.
One half-life is takes 28.8 years for strontium.
second question when it says.
Strontium.
So you weren't here at the beginning. So we talked about it at the very beginning. Like, what were we talking about right at the beginning? The first slide that we started talking about, right after the video. Yeah, what are those parts? Those things that happen. Yeah. So they're
What'd you get your
what kind of isotope?
What'd you get
Just
your
a yeah.
I know what
You tell me, Annie. You tell me.
Exactly.
and they check them off. This.
It's decaying, right?
But that is how many half-lives it is.
I'll say it first there and then she's
Yes, like he puts paper on it. And then he puts it around the
I think it's 4.
yeah, so that shit.
For sure it's 4. Yeah.
Just justify it. Why you give us 4?
And the thing I would hate is when that.
That's not what the question is asking.
What?
Isn't it asking how many will be left after?
They give you like 3 rounds.
Yeah, so the 4 is like how many half-lives I have, and then
Yeah, so 4 times. That's what percent of wait, hold on. So, So what percentage is 4 half-lives? 0.65. So you have a 10-gram sample decaying for 115.2 years. Half-life. 28.8. Went through 4 half-lives, which is 6.25%. Is asking how much the 10-gram sample will be left after 115.2 years.
They'll tell you.
No, it's okay. So, okay, overall, this is a 10-gram sample. It's going to decay 4 half-lives. That's 6.25%. It's a 10-gram sample.
So you just subtracted 10 from
And also go back.
Subtract. That's how you do it.
So that's the same thing.
What's fine, y'all?
What's the probability that the
I thought that was the answer, 0.625. 0.625 grams.
Yeah, it's a 50-50 chance, right? So that's pretty good that half of those are going to turn over
Percent.
one way or the other. So
It's percent.
it's pretty good assumption.
Percent.
It's a bad guess.
6.25%.
Odds, but
Not.
when you have so many, half one of these
Makes sense. You confident, Jason? You got it? You got it? You got it, Oscar?
Yeah.
For real? What? You couldn't add 150 earlier.
Yeah, it's my fault.
Juan shaking his head. What y'all at? Oh, you done? All right. Cool. Good. Good.
Number 6.
All right, now.
So, is there any way that they can coming down or side down? What's the shot of staying flipping it?
You can put your little ears.
Yeah, so that's your answer number 1. It's 50-50 chance that it's going to land up there, right? Are you stuck? So then, throughout your tosses, how do you follow one of those divided by? Well, by the end,
It's not.
it's very likely that it would. But there's still the chance that it's likely. There's still that 50% chance. I think they're overthinking it. So it's about that.
Alright, so you divide. Are you mad?
Yeah, see, that's why it's a little bit more.
You're not dividing.
This is if we had
Divided by 2. It would end up looking like doesn't have twice. Divided by 2 if you have.
It is half-life, but 28.8 is 4 half-lives. That's all I'm saying. It's 4 half-lives.
So 7.
It's the same thing. You just gotta just talk about different.
It's strong.
You do it just divided by half.
It's the same half-life.
You get 57.6.
Right.
And you divide that by 2 again, right? And you get 28.8. So then you divide by 2 twice like you just did. Because now you know what you have
You divide 10 by what?
You divide those in half and then because now you know
It's been sitting there for 115.
because now I figured out that this you have left, this you have left, that, right? So now I'm going to divide that. So let's take it away. That's all I have. How much is left of this half? So I divided 115 in half and got 2.5.
I see your logic behind that.
That's 4.
But we're gonna solve it all. So I don't want to go ahead and give you guys that. But I see the reason behind both of you guys. Like yours made sense, yours made sense. We're gonna figure out what's the right way.
How much divided by 2?
If you start out with 10 grand, and half that,
Guys are getting a little bit too sensitive.
so 28.2 plus 28.2 is not a hundred.
So you work.
It's only like, yeah,
Okay, we're gonna, most of you guys are done, so we're gonna go over this.
yeah, I know.
Y'all want to go on my class?
So we'll mainly go over the math questions, but we'll just start on number 2. Number 2, how good is your assumption that radioactive nuclei decay in each half-life? Anybody think they got a good answer to that?
Yeah.
Yeah, there's some good ones out there. I read them. Oscar, you've been nominated.
Number 2, right?
Yeah.
It's a pretty good assumption because it's a good estimate of how much the nuclei decay, I guess.
Yeah, because how much decay?
Half,
Half. So that's what percentage?
50%.
50%. So that's 50%. It's pretty good. It's half and half, but it's a pretty good assumption, I would say. So, yeah, we'll go on and do some of the math problems here.
If you started with a sample of 600 radioactive nuclei, how many would remain undecayed after 3 half-lives? Joseph? Or why? You were there?
75.
Huh?
75.
75. How'd you get to that?
I divided 600 by 2.
By 2.
600 by 2?
Yeah, I got 300. So that was the first one.
Okay, so what does that mean? What did you just do?
That was the first half-life.
First half-life. Good. So now we have 2 half-lives left to go through.
Then I went divided 300 by 2, and I got 150.
Okay.
150. All right. No one answered this question. Oscar.
75.
Sure?
Yes, positive.
All right.
65.
75.
So you have 75.
Anyone disagree with that? Sure? Maybe? Alright.
What's next?
If 175 undecayed nuclei remain from a sample of 2,800 nuclei, how many half-lives have passed? Gabby? 4? You sure?
Yes.
How you know that?
Because you have to divide by 75 and the 2
You said divide 175 into 2.
multiply by 2.
Multiply.
Good. That would work because you might be doing it a bit backwards, but it works perfectly. Because you could start at maybe 2,800 and divide that by 2. The way you did it, it was great because you multiplied it by 2 every time. So that would be 350. And that's 1 half-life going backwards. You can, so it works. You just kind of have to think about it the other way. So how many did that take you?
4.
4. 350 times 2, 700. Sure. And then one more time. 1400. And times 2 one more time.
280.
Go backwards here. So we can count, this is 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. HLs. You don't want to write half-lives.
Alright. Things that have number 5 correct. Things that have number 5 correct. Small. Got
3.
Got 1. Alright. You first. What's your answer? Number 5?
I think it's 3.
I think it's 3. What do you think, Juan?
I think
Trent. I think it's 4. Burgundy. I think it's 4. Michael. Michael.
Oh, I think it's 3.
I think it's 3. All right.
Yeah.
All right. Back up.
Position here.
3. Okay. 3 or 4. Anyone else got anything different from 3 or 4? That's only got a 5 out there.
Okay, so for this one, when dealing percentages like this, you can kind of ignore the numbers if your answer is going to be a percent. Because with half-lives, it's always 50% of what it was just prior. So if it's 100 starts 100%, the next step is going to be 50% of that. Then the next step is going to be 50% of 50, which is 25%. So we'll start out with 100%. So then what's 100% divided by 2?
Divided by 2.
Well, we started with 50%. That's why we got 3.
Yeah, I
Started with 50%.
That's why we
That
got
counts as one half-life. So you didn't count the first half-life. Because you went from 100 to 50% would have been one half-life, right?
Yeah, I started with it.
Let's see, so this goes to 50%. Divided by 2 again. These are the half-lives here. 25. Divided by 2 again. 12.5. Divided by 2 again. 6.25. So we got 1, 2, 3, 4.
Ah. Got it? You guys understand?
You guys got it, you just started off.
All right, so basically, if you want to just walk into, classroom, peers, if anyone who doesn't know half-life, or just learn it, you can be like, okay, just write 1 million for 3,472,000, and I'm going to solve this and see how many half-lives it would take to get to 6.25% of mass. You just write anything, Google, doesn't matter. But it's going to be 4 half-lives because all you need is 6.25% of the entire number.
So do you guys think that we would ever reach 0%?
No.
Right? So we won't. Because what's
It is asymptote.
yeah, good job.
Burgundy.
Yeah, what's an asymptote? Casey?
It will never cross the line.
So it's a line that approaches,
It will approach the line, but it will never touch it.
never touches it. And it's not parallel. So it might be considered parallel since they don't intersect. But it'll never, just like our graph back here. Well, okay. Since we were dealing with M&Ms and not radioactive nuclei, it actually did reach 0 because we ran out. But this graph would eventually keep getting closer and closer to the 0 line, but never get there. And that, well, maybe in billions and billions of years. But these half-lives are usually around 5,000 to 10,000 years. So it takes a long time for these things to decay. And then, okay, number 6.
Is there any way to predict when a specific M&M will land, mark side up, or decay? If you could follow the fate of an individual atom in a sample of radioactive material, could you predict when it will decay?
Let's answer the first question there. Is there a way to predict when a specific M&M will land marked up?
50% chance.
Well, yeah, it's a 50% chance, which maybe not be good betting odds, but it's good. That's a good estimate if it's going to land up or down. I think we should go on. Let's just do the strontium-91.
Strontium-90 is has a half-life of 28.8 years. If you start with a 10-gram sample of strontium-90, how much will be left after 115.2 years? To justify your answer. 1. Wait, I haven't got 1 yet. Yeah.
I got 0.625 grams.
0.625 grams.
Yeah.
2.5 grams.
2.5 grams. Damn. Who got what 1 got? Are you disagreeing with 1? Alright.
Oh, I got 2.5 grams.
2.5 grams. Anyone got anything different? the guy